So America just told us that symmetry is when you can form an imaginary line and cut something in half, fold it over, and it's the exact same thing on both sides. So what is our line of symmetry? Figures that have a line of symmetry can be folded into two congruent parts. What does congruent mean again? Same shape and same size. That's right. And they can fit on top of each other. Exactly. The fold line, or we sometimes dot it like this, is called a line of symmetry. How many lines of symmetry do you think this trapezoid has? Raise your hand if you want to share. Will? One. Okay. It does have one line of symmetry. Now what that means is we could fold it and it would look exactly the same on both sides. Why is this not going to be a line of symmetry, Dathan? Okay. Because the top and the bottom are not the same. If we fold it, they will not be equal to each other. Now there are figures that you will run into today that have more than one line of symmetry. Let's look at some examples. This one. How many lines of symmetry do you think this one has? Raise your hand if you'd like to share. Aaron? Okay, he says 2. It does. We can go horizontally or vertically. Now what we can't do is corner to corner, because this one just won't work that way. It will not work that way. The H has 2 lines of symmetry because the top, the bottom, and the left and the right are both the same. How many lines of symmetry does this figure have? Think about it. Aiden thinks he knows. 1. I don't think so. Darius?
5.
He says 5. Does that sound more like it? This figure has 5 lines of symmetry. 1, 2, 3, 4, 5. This is the same line, so we can't count it a second time. Look at they start at the point right here, and they go through the vertex where these 2 lines meet. So that means you could rotate this shape and you can get more than one line of symmetry. How about this hexagon? Will? 2. 3. Anybody say something different? 4. 0. Well, I will tell you, one of you is correct. None.
Me.
It has no lines of symmetry. Now look at this. Because if you fold it over, it's not going to be the same on both sides. No way to make the sides match. Okay, now we know what symmetry is. Let's look at a few other examples. My mistake. It might be very beneficial for you today to draw in your lines of symmetry. Now, could we rotate this shape and it'll look the same? Absolutely, we could. We could. So we know that there's probably more than one line of symmetry. What do you think, Alan? One. Is this the one you're thinking? Okay. Could we rotate that shape so it looks exactly like that? Yeah. America?
3.
Look, if it starts here, that means we could get one that goes here, and we could get one that goes here. We have 3 lines of symmetry. Good job, America. We call this rotational symmetry. Alexis, how many lines of symmetry does this shape have? 4. Okay, can you tell me where they are? Straight across. That looks good. Straight up and down? In the middle? Okay. That looks good. Do you think diagonal? So look here. Look how much you got here. And look how much you got here. Is that going to work? No. I don't think that's going to work. Just 2. Just 2. Eileen? This is the trickiest shape of them all. Do you guys remember what this shape is called? A rhombus has 4 of the same length sides. I am holding, for those of you at home, I'm holding a cutout shape exactly like the red one on the screen. It is a polygon. This is called starts with a P. This is called a parallelogram. A rhombus would be 4 equal sides. These 2 are the same and these 2 are the same. Now, I know that it's hard to look at a shape like the one on the screen and be able to figure out if it's symmetrical or not, but I'm going to just show you. Can you see this, Alexis, from where you're sitting? Okay, why don't you, there we go. Here we are, right here. Is that going to be symmetrical? Does that look like it overlaps exactly? Okay, come on up here, Alexis. Okay, so I just folded this perfectly. Now, is it exact on both sides? Come closer. No. Okay. You want me to fold it a different way? How about this way? Oh. It is tricky to the eye. This is one of those shapes that's very hard to see. What about this way? How about this way? None of the ways we tried, horizontal, vertical, or diagonal, none of them will work. That's going to be the same thing for a rhombus. None. How about the next shape? How many lines of symmetry? Natasha. She says 4. Well, are you thinking correct? Okay, so that means this will work as well. So there's 2. Then, good, and good. There's 4 lines of symmetry. We call that rotational symmetry. We can rotate this shape. I wish that I could turn it around right now, but I can't. We're going to make some of those on our smartboard in a minute. Okay, let's take a look at some question examples for us. And then we're going to take a look at some problems. Okay, so here's a heart. How many lines of symmetry does that figure have? Raise your hand nice and high if you think you know the answer to this one. Eileen? 1 line of symmetry. Kaylin, I know that there's not a picture of it up here, so you have to all think of this in your mind. An equilateral triangle. Equilateral. That means they're equal on all 3 sides. Do you see the word equal inside of it? How many lines of symmetry would an equilateral triangle have? One. I'm going to open this because I think it will be easier if you can see a picture of one, okay? It's coming. Be patient. I'm going to draw you an equilateral triangle, and we'll make 1 line of symmetry. And then we're going to rotate it and see if it'll work, okay? The only way you can rotate something is if when you rotate it a quarter, it's going to look the same. Or if you rotate it a half, it's going to look the same. Okay. Here comes an equilateral triangle. Okay, here's our equilateral triangle. Okay, now she said she thought it would have 1 line of symmetry. Okay, now that you see a real picture of this, do you still think only 1? I know it wasn't perfect. Oops. I didn't make it perfect either. Ah. Not perfect again. But do you see how there's going to be 3 lines of symmetry? Because look, you started at a vertex and you ended in the middle of a line. We have 2 other ways we can do that. Okay? How about which figure has 6 lines of symmetry? You know what? I'm going to ask you not to make the noises, Will. Okay? They're a little bit distracting for our listeners as well as for myself. Which shape has 6 lines of symmetry? Or is there one that you know you can rule out right away? Natasha? Say it again. Do you want to rule out B or you want to choose B? Choose B. Okay, so 1, 2, 3, 4, oops, not perfect, 5, 6. What kind of a shape was that? Darius, can you please put that away? It was a hexagon. That's right, a 6-sided figure. Which of these shapes does not have rotational symmetry for 180 degrees? That means if we flip it all the way around, kind of like a reflection, will it have rotational symmetry? Which one does not? Lingen? D. Okay, so if we take this equilateral triangle and we rotate it 180, so that means this point right here is going to be aiming down here. Will it not have symmetry anymore? It still will. What do you think, Aiden? C. Okay. Why? Let's go back to our drawing board here. Oh, we need... Oh, that's not going to work. This one, sorry. Did it start up and down or side to side? Side, like this, right? Okay. All right. Is it going to look the same? Mm-hmm. Let's go back. Let's look again. What shape is letter A? Starts with a P. It's a parallelogram. And what did I tell you about parallelograms? There is no symmetry. There is no symmetry. What kind of symmetry does that shape have? Look at your choices. Emma? None. None. Okay. Let's go back to our screen here and let's make a few different lines. There's 1. There's 2. Is this going to work? No. No, that's not going to work. What other shape should we try?
Square.
What other shape would you like to try?